In past videos, we have understood what is addition of vector, then triangle law of vector addition, parallelogram law of vector addition, depending on where the vector starts from. In triangle law, we deal with vectors, which one vector starts from one point, and from that end, my second vector starts, and so on. So if I have this vector, let us say AB, this is AB bar, and then next it is BC bar, correct? So my resultant is this AC bar. So I would say AB bar plus BC bar is equal to AC bar. So my AC bar, it has got two components. What is component? Components are nothing but parts. AB bar and BC bar, they are parts of my AC bar, correct? But then, so that means AC bar can be expressed as sum of AB bar and BC bar, correct? That is, you can see it here, and mathematically also we can write it here, right? But suppose I have a vector like this, PQ bar. Okay, how can I get this PQ bar? For example, I am at point P and I want to reach point Q there. How can I reach? In how many ways can I do that? So what I can do is from P I go to point A here. From A I move to point B here. From B I'll move to point C here. From C I'm coming to point D, and then finally from D I'll go to C. Go to Q. I'm sorry. Now here, so it is my PQ. I can get my PQ bar using this PA bar plus AB bar plus BC bar plus CD bar plus DQ bar. So that means this PQ bar has 1, 2, 3, 4 and 5 components. I had, for AC bar I had AB bar and BC bar. Correct. So a vector can be expressed as sum of as many vectors as you want. Correct. But then, is it quite convenient? We have to go for something which is convenient. We all work for convenience. So what would be the most convenient thing to do? Because I can have my this Cartesian coordinate system, that is my origin at O and my positive x-axis and y-axis, or I can have this coordinate system here. This is my origin, this is my positive x-axis, this is my positive y-axis. Obviously this is my negative x-axis and this is negative y-axis. Now here, suppose I have a vector let us say OP bar. Now I need some more data here. Okay, I'm taking angle made by this OP bar with positive x-axis and I'll call this theta. Now what I'm going to do is I'm going to project this point P on x-axis and y-axis. What do I mean by that? So I'm just drawing perpendicular here and one perpendicular here. From point P, I'm drawing perpendiculars on x and y axis. Right? Now here, suppose this P, I have this point Q here and one point R here. Okay. So now I can express this OP bar as OQ bar plus QP bar. I'll write it down here. Suppose I draw this vector here and this vector here. OP bar is equal to OQ bar plus QP bar. So fine, my work is done, but then before going ahead, I need to know what is my length OQ and length PQ here. So now you consider this right angle triangle OQP or OPQ, whatever you call it, with Q as your right angle. Yes, I have this right angle here. So in this right angle triangle, I have sine theta is equal to this opposite side divided by hypotenuse. So that would be PQ upon OP, and cos theta is equal to OQ upon OP. Now what is my PQ? My PQ is nothing but this OR, correct? So, alright, I'll write PQ is equal to, therefore PQ is equal to OP sine theta and OQ is equal to OP cos theta. Now what is this length OP? Is it not magnitude of this vector OP bar? Yes, it is. So for getting components of a vector, what I need is, I need the magnitude of the original vector and inclination of that vector with the positive x-axis, right? So therefore I can say OP bar is equal to OP sine theta. So OQ, right? OQ is OP cos theta plus OP sine theta. Now again I'm expressing this OP as magnitude of OP bar. So that would be OP bar magnitude cos theta plus OP bar magnitude sine theta. Okay. Or to be more precise, I would, instead of using magnitudes here, I'll simply write it like this: OP cos theta. Is it not its x component? OP x plus OP y. So OP x bar and OP y bar. This is my OP bar. So what do you need for resolution of vectors? So this process, what I've done here, that is called resolving vectors into its components. So my given vector is, it would be given by sum of its x and y components. So that's about resolving vectors. Now this topic we are going to be using repetitively in all our exercises in kinematics and mechanics, right? In the next video we are going to talk about a few problems on resolution of vectors and parallelogram law of vector additions. Thank you so much.